image profile. The image profile tells the image processing. It is very important uh, component, and it tells us the information about a image. You see, this is a black and white are there, and if you match with the graph, the first one is your, you see, first is a white color, so that is why the of the top whites, and there's a black color in the below bottom, represent that this is zero. So first you see the first is a peak form, then it is gradually decreases, reaches at the minimum point of black color zero, and then it rises and meets its maximum point W, that is 255, and again reaches and reaches zero, because it is when black color appears, the graph reaches zero. When white color appears, the graph reaches its maximum value 255. So we have already discussed this, the orthogonal and non-symmetrical, and this is a forward and inverse transformation. We have already discussed. We have two inverse functions. One is forward and another inverse, under inverse transformation, another is forward information. If the forward transformation, what does it convert to one transform to another form, one domain to another domain, and after that we have to make its inverse to get its original form. I've already discussed in this example in the last class, I think. uh, Partial domain enhancement we have discussed. I think yes, we all have to discuss, and some techniques in partial in image enhancement is clipping and thresholding. There is a fixed value. Please recall that is a fixed value. You see here, this image, this is the effect of thresholding. We have taken T is 110, the fixed value, the threshold value is 110, and you see the first first matrix. It is the original gray label value of the some pixel. Not all the pixel are given. The value of some pixel is given in the original image: 0, 10, 50, 100, 5, 95, 150, 200, 110. These are given in the uh, some image value, some pixel value, gray label value of the pixels, and here threshold value taken T 128. After thresholding, we get, you see, all the value, all the pixel value which are less than 128 is converted to map to zero, and all the pixel value, gray label value of the pixel which is greater than 128 is mapped to 255. So here we will get a value, a picture only only either the minimum, that is black color, or the maximum gray label value, or the white color. So this is thresholding. So you see, this is constanting is a low constant image. How it is converted to enhanced image by using either one of the techniques, clipping, thresholding, and we have already discussed the digital negatives. And digital negatives is nothing but when the original gray level value is subtracted from the maximum value, that is 255. So the pixel value, the pixel having gray label value 10, having a digital negative value 255 minus 10, 245. So the pixel value 10 and 245 is digital negative of each other. That is, if you take a darker value, if you take a darker value, then after digital negative, we will get a brighter value. That is zero. The value of the digital negative value of zero is 255. So that is 0 means black color and 255 means white color. That is the negative color of a black color is white color. So similarly, suppose there is a 50. 50 is the pixel value, gray label value of a pixel, and the value is 255 minus 50, 25, 205. So this is the digital negatives. You see, we have a clear picture of digital negatives. So this is the example. You see f of xy, the gray label value of a first image is given of some pixel in the example, because this picture may contains more pixels, but we have taken the gray label value of some pixel 1 2 3 4, only 16 pixels, 4 cross 4. A 4 cross 4 matrix is taken to represent 16 individual pixels, and it is converted to its digital negative. You only uh, remark that that is 0 is converted to 255, 10 is converted to 245. The digital negative value of 10 is 255 minus 10. So each value is subtracted from 255, and you see the new matrix. So this is the digital image. You only see that is the white color in the first image is converted to corresponding black color, and the darker pixel is converted to brighter pixel, and vice versa. Uh, Intensity label slicing. A variant of thresholding is intensity label slicing is double thresholding. It is used to maximum highlight of a range intensity value of a interest in a range. So if you compare with thresholding, thresholding is associated with a fixed value. In a previous example, please recall we have taken 128, but here in this operation we have to take a range value. Suppose 120 to 150. If any value is within this range, it is mapped to 1 or 255. If any value is beyond this range, is mapped to 0. But in thresholding, we have taken 128. If any value is greater than 128, we have to map it the maximum value 255. Other hand, that is if any value is less than 128, suppose 120 is immediately mapped to the its minimum value, the least value 0. But here we have to take that threshold value, gray level value in a window, in a range. If any pixel value is lies between in that range, it will map to its maximum value. So you see, if all the gray label value in a window A to B, suppose you take 100 to 200. If any value is lies between 100 to 200, is immediately mapped to 255 with maximum value. And other gray level value with outside of the beyond of this range, suppose you have to take 100 to 200, suppose 220 is immediately mapped to 0, 99 is immediately mapped to 0. So this is the difference between the thresholding and this intensity level slicing. So it is same as thresholding, it will give the same result either 0 to m, but there is some technical difference. There is a fixed value, here is a range value, some range. Uh, um, Mostly this technique is used to remove unwanted element from the image so that the useful information become prominent. So the application of this technique is to uh, to eliminate, to remove unwanted elements, to get the useful information, and the useful information become prominent. application are enhancing certain features which are based on gray label values, source of mass of water, satellite of image, uh, 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 cancel cells in a monogram image. So this is the application of intensity label. Suppose you see uh, that is if you are interested in the some part of the yeah, an image, you will get the information and remove the unwanted element, that is technically known as clutter. Please write your name and registration number, or then come to the filtering. Filtering, as you know, is a process, as the name suggests, it removes some unwanted component or small details in an image. In digital image processing, filter is basically sub-image and is known by various names such as mask, kernel, template, and window. That is, as the name suggests, filtering, it removes some unwanted component or small details in an image. Basically, it is used to get enhanced picture, that is to enhance the quality of a picture. And it is two types. One is frequency domain and is partial domain. So partial filtering, one of the main tools used in variety of applications such as noise removal, bridging the gaps, object boundaries. So these are the purpose of using partial filter to remove a noise. If there are any gap, some pixel is missing in between two pixels, some pixel is missing. So the strategy called the gaps. You can bridge them. And sharpening of edges. In some edges, in some images, the edges are not clear. The edges are not properly given or properly comes. So for that purpose, partial filtering is used. And for this purpose, we have using a mask, a mask of any square size. It may be a 3 cross 3 or 5 cross 5 over the whole image, pixel by pixel. At each pixel, the corresponding value of the mask and the image are multiplied and added up to the replace the original gray level value of the pixel. This process is known as convolution. This is important. That is, no, we have to put a mask, a square mask, a size uh, square size mask, either a 3 cross 3 or 5 cross 5 over the whole image. And the gray label value of that pixel uh, will be changed. And how it is changed? The image are multiplied and added. The replace value is added and multiplied. We have a better example. And the new gray label value is replaced by the old one. The old value is replaced by the new one, and the process is known as convolution. Let us see. You see, there is a original image, and after convolution, we'll get a new one. Suppose this pixel value, this is a mask. Suppose this is a mask, and I want to interested the pixel the to change the pixel value of the pixel which is marked by a gray label. You see, gray color, the original image, and This is suppose the pixel at position XY. I am interested to change the uh, gray label value of this pixel which is at position XY. So we have to do the partial filtering. How we do partial filtering? We have some better example after that. How the new pixel value is calculated. But now you assume that suppose the new value is calculated and you see the old pixel value is replaced by the new pixel value. Pixel value means that is the gray label value. So you see the image after filtering, the image B, and you see the gray label value of that pixel have changed, which was in XY, which color is gray. Now it is converted to any other black color or darkest color. So by this process, we create a new image where gray label value of the pixel are calculated from the values under the max. Each suppose a mask contains suppose a 3 cross 3 mask are there. A 3 cross 3 mask contains nine pixels. A 3 cross 3 mask contain 9 pixel, and each 9 pixel have the gray label value of these nine pixels have been replaced by the new value. It is calculated by multiplying and adding. We have a uh, uh, example after one or two slides. We will discuss about that how it is calculated. But once it is calculated, the new value is given to the existing pixels, and you will get a new image. So if that is written where gray label value of the pixel are calculated from the values under the mask, this value under the mask are modified by a function called filter. So if the filter function is a linear function, then it is called the linear function, linear filter. Otherwise, it is called non-linear filter. So this is the partial filter, which divided a smoothing filter, low pass, linear filters, average filter, median filters. We'll discuss one by one all the filters, and it is comes under partial filter. You see this block diagram. The partial filter is first divided into two parts: low pass and high pass. Which is known as smoothing and sharpening. Smoothing is further divided in two parts: linear filter and non-linear filter. Average filter is example the linear filter. Non-linear filter is a median or min max. Sharpening filter is also there, high pass, that is first derivative and second derivative filters. So let us first discuss one by one. Let us first come to smoothing, low pass filter. So as you know, the spatial filter is divided broadly into two types. One is smoothing and another is sharpening. Uh, Smoothing is nothing but it's a type of filter used to smooth or blur the image, therefore called smoothing filter. And this filter basically used for noise reduction, which can be done by blurring with a linear filter, in which operation performed on the image pixel is linear, or a non-linear filter. So we have a good example to illustrate it after some slides. Sharpening. This filter is to highlight the transition intensity. There are based on first and second derivative. This happening is a filter, is a high level filter. It's a uh, it's way of function some complex. To calculate a new gray label value, we have to use some mathematical function. But in smoothing, to find a new gray label value, we have to use some statistical function like average, mean, average or mean, median, like that. We'll discuss about that. So uh, this is a picture to give us some more information about smoothing and sharpening. You see, uh, there is an image of a flower. Low pass filter leads to the softened edges and noise removal. So if there are any noise means that is some pixel value is missing. Some there is a bridge between any there is a gap, and uh, so this for this purpose the low pass filter is used. It leads to softened edges and noise removal. But you see, sharpening filter, high pass filter leads to edge enhancement. Let us discuss about more using the mask, how the new value is calculated of a pixel of an image. As we discussed, linear filter is a spatial domain process where a filter with some integer coefficient value known as mask. Basically, mask is used, mask word is widely used, values to apply to input image to generate the filter output image. And filter size is a 3 cross 3 or 5 cross 5, 7 cross 7 or 21 cross 21 word size. And a filter is centered at a coordinate xy called the hotspot. You see, there is a mask of 5 cross 5. That means now this mask contains 5 into 5, 25 individual pixel of an image. And the centered, you see the center is known as hotspot. The center pixel is known as hotspot. That means the pixel which one is the hotspot, we are going to change the gray label value of that particular pixel. Now that is we are going to change the value of the pixel which was in the hotspot, which was in the center. After that, after changing that value, the mask is shifted to either right or to left or to bottom or to down to change the position of the hotspot. Suppose if this is hotspot of an image, we have to shifted this mask to a right, and the pixel which was right to the hotspot will become the new hotspot. So now assume that the centered pixel is a hotspot. That means we are going to change the gray label value of that pixel only. Now, linear filter of an image of fxy of size m cross n and filter max of size m cross m is given by, we can you see the each value is a summation of f of xi and y of yj into wij. It is multiplied and then summed, where 0 lies between 0 to m minus 1 and y lies between 0 to n minus 1. What is m and n? Is a dimension of the image. And what is m cross n? Small m, that is it, nothing but it is the dimension of the mask. So you see the last line written that the right hand side of equation 1 denotes the set of coordinates covered by filter for a 3 cross 3 filter with coefficient wij with the output image at coordinate xy is calculated as. Okay, so this is an summation f of xy yij into wij, and if we uh, expand it and want to remove the summation, you will get this. Although it is seems is a complex equation, but actually it is easy. We have a good example to find the gxy from f of xy. F of xy is the new is the old the original intensity value, where g of xy is the new one, and using this function we have to change the new the pixel value, the gray label value of the pixel at the hotspot to a new value gxy. In simple word, suppose the f of xy is the intensity level value or gray level value of the pixel which was in hotspot. gxy gxy is the new gray level value of that pixel which is on the hotspot by using this function. So it seems the it is complex, but it is actually very easy. We'll discuss. What are the steps for linear filtering? Position the marks over the current pixel so that the hotspot, let it W00, coincide with the current pixel. So if we keep a mask on the image, there should be a center. There should be a center of that mask, and the pixel which present in that center pixel is known as the hotspot. From all product of the filter element with the corresponding element in neighborhood, we have to make all products of the filter elements with the corresponding element in the neighborhood. All the pixel value of the neighborhood will be added and multiplied. You see, add up the product after multiplying. Go add up all the product because it is summation of the product. Please recall the mathematical function gxy. There is summation of fxy into wxy. So after multiplied, you have to add up the product and store it at current position in the output image. So divided by the scaling constant sum of the coefficient of the mask, and this must be repeated for every pixel in the image. So this step 1, 2, 3, 4 must be repeated for every pixel in the image. So let us see. This is the proper example, a good example of the previous. See here, we know that this filter use some mask. You see example 1. The question is apply given 3 cross 3 mask W on the following image fxy. You see in fxy 1, 2, 3, 4, 5, 1, 2, 3, 4. That is a 5 cross 5 matrix is given, whose represent 25 pixel of the image. You know that the image is consists of uh, many pixels, a lot of pixels, but we have to take only 25 pixel for this example, whose values is given in a matrix from 5, 1, 2, 6, 7, 4, 4, 7, 5, 8, 2, 6, 20, 6, 7, 3, 1, 2, 4, 5, 10, 2. This is given, and the max value is given 3 cos 3. We have to we know that we have to take a mask, either 3 cos 3, 5 cos 5, 7 cos 7, 21 cos 21. So as our image size is only 5 cos 5, we have to take a mask of 3 cos 3 whose value is given. So first we consider the left 3 cos 3 neighborhood in image fxy. So if we keep a mask, you see, so first we consider the left 3 cos 3 neighborhood. We have to keep a mask in the first left 3 cos 3 neighborhood. You see, if we keep a mask, you see the image A. Please see the image which is marked at small a in the solution part. If we keep the a 3 cos 3 marks on the in the first 3 cos in 9 pixel, 3 cos 3 9 pixels, the 4 is at the center. The 4 which is marked at circle, you see, the 4 which was marked as a circle is known as the hotspot. So the pixel which marked at circle whose gray label value is 4 is marked as hotspot. And you see, we have to multiply these two images and added. You see, that is Fij is 4 and it is corresponding value is 5, 1, 2, 4, 4, 7, 2, 6, 20. You see, we multiplied this value with Wij, that is 1 by 9 into, you see, 5 into 1 plus 1 into 1 plus 2 into 1 plus 4 into 1 plus 7 into 1 plus 2 into 1 plus 6 1, all they multiplied and then added. So all the values is 49 divided by 9. It will be 5 point something, but it should be rounded or flooring value taken rounded value 5 is there. That means the new value of the pixel which was in the hotspot is now 5. Initially it was 4. Initially it was 4. Now it is 5. The new value of that value is 5. Similarly, the work of 4 which on the hotspot is over. We have to shifted the mask towards right. If the mask is shifted to our right, the 7 will be the new hotspot. The 7 will be the new hotspot. The pixel which was 7, you see, it is marked by 7 in the figure B. The solution part, you see, figure 6B. Similarly, the 7 value is will be replaced a new value, same as calculated. You see, it is calculated in shift the mask 1 pixel towards right so that the gray label 7 coincide with hotspot, and 7 will be the new hotspot as we discussed. Calculate output for that pixel position. And replace in output image. So the 7 value is calculated 1 by 9 into 1 into 1, 2 into 1, 6 into 1, 4 into 1, 7 into 1, 5 into 1, 6 into 1, 20 into 1, and 6 into 1. And the new value of that position 7 is 6. You see 57 by 9, and the rounded value is 6. Similarly, we have to shifted the mask or all the pixels, and the new value is calculated for that. And the output of every pixel is calculated 5, 6, 7, 4, 5, 6. So by shifting to the mask over the whole image, so we have to get a new value 5, 6, 7, 4, 5, 6, and you just recall the first hotspot value was 4. Now it is converted to 5. You see there's a 5 in that position. Then 6, then 8, then 5, then 6, then 7, then 5, 4, 5, 6. So by shifting the mask right, left, up, and down, the hotspot value changes, and each hotspot value is now changed to a new value, and we'll get the gxy now from from f of xy. So gxy is the new value of the pixels. So in this way, all the pixel value is changed and to generate a new and enhanced image. So the aim of image smoothing is to diminish the then known as the smoothing. As you know, it is you see the, please recall the block diagram. Smoothing, spatial feature divided into smoothing and sharpening. We are now discussing smoothing. It is used to diminish the effect of camera noise, spurious pixel value, because all the pixel value is calculated the new value by taking the consideration of this neighborhood pixel, and some spurious pixel value. Suppose some pixel is spurious, that is you do not expect that gray level value of that pixel. That pixel value can be changed. You can be modified. You can be edited by using the mask as we discussed in the last slide. Then it's done by neighborhood averaging filter. So as you know, the averaging filter is the part of the low pass filter smoothing. You again come to the block diagram. You see the this low pass filter is done by the linear filter and non-linear filter. Linear filter is the average filter. Just we are discussing average filter, linear filters. Average filter, you see. So now we are going to discuss what is the average filter, that which comes under smoothing low pass filter. So average filter is a low pass filter. As the name suggests, average filter, the new value of a spurious pixel value is calculated by taking the average of its neighborhood. You see, each pixel in the smoothened image gxy is obtained from the average pixel value in the neighborhood of xy in input image. Such a mask is known as a mean filter or average filter. So as we discussed, that a gxy is calculated previously. In general, it is not calculated by only average. In smoothing, we have done where it is multiplied with a mask value and then added. But in the mean filter or average filter, we have to only take the average value of a of its remaining neighborhood image, sorry, pixels. Suppose suppose xy is the pixel location or position, xy, and we have to take the average value or mean value its neighborhood pixel. We have a good example. We'll discuss. But before that, you see what are the purposes. What are the purposes of smoothing filter? Low pass filter. It reduces sharp transition in gray level. Sharp transition. Suppose all the pixel gray level value is 20 in a range 20 to 60. But suddenly you see there's a pixel whose value is 255, 254. So this is a sharp transition. It reduces that. It reduces the noise, the unwanted component. It blurs the edges. This is a side effect. This is a side effect. You can tell this is a demerit. Sometimes you see the edge are blurred by this filter. It helps in smoothing false color. It reduces irrelevant detail in an image. So irrelevant detail which are not relatively, which are not that is, it reduces that. So these are the purposes of a low pass filter or smoothing filter. Sometimes you get question, what are the low pass filter, what is smoothing, what are the its purpose, and with an example. So you can explain it. As we discussed in the last slide, blurring, you see it is a side effect of smoothing filter is used in pre-processing steps in following application. Removal of small detail from an image prior to object extraction. Intensity of smaller object blend with the background and larger object become blob-like and easy to detect. So this is the first application. Bridging small gap in linear to curve or curves of the boundaries of object and text. This is also used in bridging of small gaps. Small gaps in the boundary can lead to the enormous result in object extraction. Smoothing fills up and smaller gaps and help in producing correct result. So these are the applications. Smoothing linear filter have an important disadvantages. We know that the filter are divided into two parts: linear filter, mean filter, average filter. We have discussed, and now the nonlinear filter, the median filter. So smoothing linear filter have an important disadvantages. Image structure such as individual points, edge, and lines are blurred. Overall quality of an image reduced in some application. These side effects are not tolerated with the limit of users of linear filter. So these are the demerits drawback drawback of nonlinear filters. Let us see discuss what is the how the linear filter and non filter work. This is an example of nonlinear filter, median filters. Instead of taking the average mean, if you take the median, please recall median is nothing but this is the mid value of a range. The mid value. The mid value is the median. Please recall the mean is the average value. Median is the mid value. Mode is the no the frequency. How many times? That is the mode. Uh, Here median filter are edge preserving smoothing filter. Here the label is set to median of a pixel value in the neighborhood of the pixels. It is exactly same as the average filter we have discussed in the last session or last slide. In place of taking average mean, we have to take the median. But in the place of taking average, we have to take the median of the neighborhood pixels. This is called the median filter. It is possible to design a filter that removes only noise and retains all the important image structure intact because no filter can discriminate which image content. Median filter replaces every pixel image by the median of the pixel in the corresponding filter region x of xy. Xy is a region, is a position of that region. We have to replace the pixel value, image pixel value of every pixels by using the median filters by taking the median value of that neighborhood pixels. What are the advantages? It is an excellent noise reduction capability. It preserves edges which was a problem in last filter. It introduces less blurring than smoothing linear filter. So linear filter, you please recall the linear filters. The average filter has this effect, blurring effect, but it introduces less blurring as compared to that. It is very effective in the presence of impulse noise. We'll discuss about the type of noise. There is a noise type impulse noise. Its drawbacks are it performs poorly if number of noise pixel in X. That is, if the number of noise pixel is more in a, is greater than the half of the number of pixel in the window XY. That is, if the number of noise pixel is more, basically is greater than the number of pixel in the window XY. What is window? That is total image. And what is xy is the position. Okay, is the region which are interested. If suppose in total window xy there are 100 noise pixel, suppose, and your region xy, suppose there are 60 noise pixels, is greater than half of the total noise image. At that case, this filter performs poorly. If the number of noise pixel is greater than the half of the total noise pixel in the window, then it's perform very poor. It performs poor in presence of Gaussian noise. We know that there are impulse type of different noise. We'll discuss impulse noise, Gaussian noise, for which usual Gaussian transformation is used at previous class. So it performs poorly. If there's a Gaussian, we'll discuss about the Gaussian noise, impulse noise after that. There is a uh, there is a topic noise, type of noise. We'll discuss about that. But if the Gaussian noise are present, its performance is low. So these are two major disadvantages, drawback of median filter. Steps to implement median filter. How to implement the median filter? What is the work of median filter? How do the median filter works? This is the steps. Sub the values of the pixel in questions are its neighbor. You have to sort first because to you know that to please recall the statistics part median. If there is a raw data is given to you, some raw data, and you are asked to find the median is calculated first by sorting the raw data. If the raw data, some data is given to you, and you have to ask to find its median, first your work is to sort that. Otherwise, you cannot find the mid values. Median is nothing but is the mid values, you know. So first we have to sort it. So after sorted, you have to find the median. You know that is if n is odd, n plus 1 by 2, or there are two values if odd is even, like that. So please recall. So first we have to sort the values of the pixel in the question and its neighbors. Determine their median value. And after sorted, it is easy for us to determine its median value. Assign median value to that pixel. But this is three simple steps. Let us see. This is a small example. F of xy, f of xy is the pixel value, gray label value of some pixel. 9 pixels are given, and 0 is the middle centered. That is, we have to want to change using median filter of the image of the pixel whose value is 0, which is center. There are two pixels having zeros, but I am considering the pixel, the gray label value of the pixel 0, which was in the center. So you see the neighborhood value 372100958. So the other 8 values are its neighbor value, and we have to take all the 9 values 32372100095. Now I am going to find its median. It is simple. First we have to sort. We have to arrange it either in descending or ascending order. So in ascending order, you will get 0 is the first value, it is the minimum, then again 0, 1, 2, 3, 5, 7, 8, 9. So are there 9 value, 9 plus 1, 10 by 2, fifth. The fifth one is the median, that is 0, 0, 1, 2, 3. 3 is the median. So the new value of 0 is now will be replaced by 3. You see the gxy in extreme right side. The 0 will be replaced by 3. Similarly, all the other pixel value will be calculated. Here in the example it is not calculated, it is marked by a star, but in the same manner you may replace the other values by shifting your mouse toward right, toward left, toward up and down. So all the pixel value like 0 here will be replace its median value of its neighbor pixels, and you will get the gxy, a new image. So after filtering, we will get a new image there. So here is another example. Compute the median value of the marked pixel shown below using 3 plus 3 marks. You see here, in this fxy which is given 18, 22, 33, 25, 32, 24, it is given. We have to use a median filter here. That means you have to keep a mask. Suppose a 3 cross 3 marks. Suppose if we keep a 3 on 3 marks, 128, you see, the pixel 128 will be the centered hotspot, and the median of other 18, 19, 33, 34, 128, 24, 22, 19 and 32. It is sorted first, and the median of this value 24. Then we have to shift the mask to our right. It was initially the center was 28. If we shifted the mask to our right, the 24 will be the new hotspot. And the median of that 22, 33, 25, 128, 24, 172, and the median after sorting the median will be the 31. So 24 will be replaced by 31. 128 will be replaced by 24 at the previous case. I. Similarly, if we shifted the pixel to a right, 172 will be the new hotspot and it will be replaced by its median value. You see 31 and median value of is 26. So in this way, all the values of the pixel value will be replaced by its median value. And you will get a new GXY. So this is the median filter, non-linear filter. Your average filter or mean filter is a linear filter. Besides these two, we have two other filter, max filter or mean filter. It is minimum or maximum filter. Max and minimum filter are defined as GXY is calculated minimum of x plus I, y plus j. J belongs to XY, that region. So the region is XY here. That is, you are interested in that region. That is minimum of x plus y and y plus j. What is IJ? IJ belongs to that region. Similarly, for max filter, GXY is maximum from x plus y, y plus j, I plus to that regions, where x of xy denotes the filter region. Usually size of 3 cross 3 pixel. We have to take a 3 cross 3 pixel, 3 cross 3, same like a mask. Minimum filter or mean filter removes all salt noise. What is salt noise? White dots with large gray label value. As you know, the color, as the name suggests, the color of salt is white. It is known as a Salt noise. Salt noise means whose given value is maximum gray level value. With dot with large gray level value. You know that 250 the maximum gray level value is 255, which has a white color. Suppose there is a white spot. Suppose there is a white spot, that is known as your salt noise. So minimum filter, the work of minimum filter remove the salt noise, because any large gray label with 3x3 filter region is replaced by one of its surrounding pixel, which is the smallest value. That is, the region is simple. That is, any value, any value is replaced by the minimum value. Will replace the minimum value of that region. Suppose there are 9 pixel values, the pixel value which at the center will be replaced by the minimum of them. In previous case, it was the median. In linear filtering, it was average, but now it is the minimum value. So the that is why it is the region for removing salt noise. In the other hand, as the side effect, minimum filter introduce dark structure in the image. Dark structure, because you know that the pixel value is replaced by the minimum value. If the minimum value is 0, all the replaced by the black color. If the minimum value of the 0 of that region, all the other pixels is replaced by 0. So you will get a black color. So that is why it introduces a dark structure. It introduces a dark structure. And the max filter is exactly plays the reverse. The role of the reverse role of the minimum filter. It removes the paper noise, black dots with small gray label values. Because any black dot within 3x3 filter is region is replaced by its one of its surrounding pixel with the largest value, with the brightest value. So there should be no any darkest value. It will replace by the gray level value, which are the maximum, which are the brightest. So that is why the black spot is replaced. And this is as paper, the color of paper, you know, black, which so there are two type of noise: salt noise, which will be removed by main filter, and paper noise, which is replaced by the max filter. White dots or bright structure are widened as a side effect. Obviously, that is, if there is a 255, so it is all the pixels. Suppose the neighboring pixel there is a value 255. As it is maximum, as it is greatest, after max filter, all the pixel will be mapped to 255, and you will get a bright structure, white structure. So it is a side effect. And black dots, paper noise will disappear. Obviously, black dot will disappear because it will replaced by the maximum value, and maximum value means the brightest value, white color. So the black dot will be removed, unlike your minimum filter where the white dot will be removed. And this is about the main filter and max filter. So far we have discussed the average filter, median filter, and now mean and max filter. You see, it is the same example which is given in median filter. The 0, please recall, in the median filter 0 will be replaced by 3 because 3 is the median value. But you see, in minimum, as 0 is the mean, so 0 will be replaced by itself, 0. But in max filter, the 0 will be replaced by 9. You see, there is a two output GXY, one for mean filter, another for max filter. So please recall that is if 0 you replace by the minimum value, so they are used to use the salt noise and pepper noise, you see. So replace by the 9. So no black color is there. The maximum by the, if there is a black color, to replace by 9. So 0 will be replaced by 9, the highest pixel value. So 0 means the black color. Now it is replaced by 9. 9 is more brighter than 0. I am not telling 9 is brightest, but 9 is more brighter than 0. 0 is the minimum. You will get a black color, and 255 is, as you know, you will produce a white color. The in between value is produce the different other color. That is, if you go away from 0, you will get brighter. If you come down from 255 to 0, you will get darker. So 0 will be replaced by 9 is the max filter. So no doubt 9 is more brighter than 0. Similarly, in mean filter, 0 will be replaced by itself because 0 is the minimum. So suppose think if there is 7 in place of 0, it will also replace by 0. 0 is more darker. It is darkest. So this is the mean filter and max filter. So we have discussed about all. Now it is all about the filter. We'll discuss the some other techniques. So you all write your name and registration number. And have you all got the PPT? I have already sent the PPT to uh, your
No,
email
sir,
ID.
I haven't received that.
Have you sent your mail ID?
No, no, sir. I was late. Joined late.
Please, please write your mail ID in the board.
It's marva
Uh,
sachin
so,
at the rate gmail.com. I wrote that.
okay,
Thank you, sir.
okay, I will send today.
Thank you, sir.
Uh, Histogram. The next is histogram processing. Histogram of an image represents the number of times a particular gray label has occurred in an image. You know that histogram is one type of graph. Uh, it is a graph in which x-axis represent gray labels and y-axis represent number of pixels for each gray label. That is, the x-axis represent the gray label values, and y-axis represent number of pixels for each gray label values. How many pixels of particular gray label values? For example, suppose 10. 10 is a gray label values which is represented in x-axis. Suppose the number of pixels, the number of pixel 25, that is 25 pixels have gray level value 10, and that 25 will depend by the y-axis. You see here. Here is a here is an image having some values. You see, I am representing the pixel only 12, 12 pixels, and each have the different gray level value. You see, the black color which is represented by zeros, and the highest color you see 6, the brightest color. 6. Then 4, you see 4 is more darker than 6. 1 is more darker than 2, and then 4, then 3. And the corresponding pixel having 2 is more darker than 3 and more brighter than 1. So if you compare the image with the its gray level value, you will get a clear idea that how it is 0 and 1, 2, 3, 4, 2, 5, 4, 6. Among all the 6 is the highest, and it is depending by white color. So we have to uh, form a histogram for this image. A table is generated with RK and NK. What is RK? It contains all possible gray level value 0, 1, 2, 3, 4, 5, 6. And what is NK? The consist of number of times that gray level value occurred in that figure. We know that 0 has 6 times, 1 occurred 1 times, and 2 1, other are 1, I think. 2 are twice. You see, the RK value 0, 1, 2, 3, 4, 5, 6. NK, the number of times 0 occurs 6 times, 1 occurs 1, 2 occurs 2 times, 3 ones, 4 ones. There are no 5. So the NK value of 5 is 0. And there is 6 occurs only once, and 6 has value, NK value as 1. And to see the corresponding histogram. Zero, you see the x-axis, which represent the pixel value 0, 1, 2, 3, 4, 5, 6. And y-axis represent the number of times, NK. NK stands for the number of times. 0 occurs 6 times, so that is why you see the height of the bar for 0. 1, 2, 3. 1 minute. Okay. So this is histogram. Histogram value. What is the function? What is normalized histogram? We will discuss in the next class. This is the
HQ, sir.
histogram. Um, yes.
Sir, is there any group, sir? WhatsApp group, sir?
Yes, I am added by someone in the last class, but I am not the admin.
Sir, please add me.
I am telling you, no, I am not the admin.
Then send me
Okay.
the number of admins so I can request
So
them.
I will send. I will send. And
Sir,
if
one more question I have, sir.
huh,
Sir, my question is regarding the assignment marks is not updated yet. I have request so many times to the RC number one. Even I have complained in the igram portal also. I sent the email several times, but had not respond any. I request you
no,
to please convey this message to the director.
no, actually, the last class, some student also complained for the same. I have talked to the person who are responsible for that from that LC. They told that that is the assignment mark from 22 to 24 has already manipulated or something. I what told that is they're already the assignment will be appear soon. I thought that he told me.
Sir, it is
And
going to 2 years, sir. Sir, it is going to 2 years.
so it actually yeah, the same problem. There's actually this problem was also happened in your previous batch. I have taken this class for more
Then
than 2 or 3 years.
what is the use of technology, sir? It has been
But
2 years, so long time, sir, to add the numbers in, sir.
it is unfortunate.
Boss, visit
So I yes,
RC1 first, na? Then ask them what's the problem, why they don't update your
I have
marks.
already talked. I have already talked. They are
Uh,
going. Oh yes, it will coming soon. It will come soon. The
I,
same
sir,
message
I
like
have
that.
sent the mail to the all the respected authority, and even I have a complaint on the igram portal also. They reply there is a technical glitch. That is the not appropriate answer to me, sir.
तो विजिट ना
Mhm.
ब्रो, विजिट कर लो एक बार विजिट कर लो, सामने सामने से बात करोगे तो उसकी बात अलग हो
It
जाती है.
is it is so far away from me.
ओके, तो टाइम
Mhm.
निकालना पड़ेगा यार, यहाँ थोड़ा सा लेट होता है, हर चीज में लेट हो रहा है. आप जान ही रहे हो, 2 साल से पढ़ रहे हो तो आपको पता
Now,
ही है.
sir, I am we are living in a 21st century era. That is the technology era. We can
Technology, yes, yes,
solve the
yes. Yes,
problem,
you are
sir.
right. Hmm.
दिस इज इग्नू बॉस, यू नीड पेशेंस हियर.
It has been 2 years, sir.
Hmm. No, no, I am telling you that this problem is not only for this batch. I have been listening the same problem for last two batches.
So you should talk to the appropriate authority
I have already
to.
talked. I have already talked. So
Otherwise, add the
the
responsible
student,
person to
I am already
we
talk,
can
I am
fix.
I talked yesterday also. That is, these are the students are complaining for this. So they told me this is
Otherwise,
the
you give
problem.
sir. I request to the. Otherwise, you give me the number. I personally
Mhm.
talk to the sir because I tried to all the reflecting number on the website that is out reachable out of reachable. Sorry.
Acha, 1 minute. I am giving a persons. 1 minute. 1 minute.
There's no any groups where we can student can ask their question and resolve their problems, sir. Very bad scene, sir.
Uh, yes, it number. Have you pen or paper to write?
Yes, sir.
991110.
991110.
Double
Yes,
six
sir.
zero two zero
66020.
zero. Hmm.
I am repeating, sir. Please
He
verify,
he
sir.
he he double
Double
nine
nine
double 10.
जी sir.
66020.
जी sir. What is the name, sir?
Tushar.
Tushar.
Tushar, हाँ. So
He's
please
the
talk to him.
responsible who is handling the assignment marks.
He may solve your problem.
RC1
So,
Delhi, है ना?
हाँ, Delhi merit. I do have this is merit RC1.
Okay, sir. He is available today or not, sir?
He may not be available because he is also busy in taking class. So please contact Monday
Okay,
or
sir.
evening or today's evening.
Okay, okay, sir.
Okay.
Thank you.
Okay.
No, I request you to, sir, please convey the message to appropriate person.
Okay.
It will
Okay. I will
to
convert
resolve
again.
the problem as soon as possible, sir.
Okay.
Thank you, sir.
Sir, please send the PPT via mail. Okay.
I've already sent that. So please write your mail and I will send
Yeah, I
today.
sent that. Send that on
Okay.
chat.
Okay. Okay. No, I'm sending now in
It's Marva.
10 or 15 minutes.
It's marvasachin@gmail.
Yeah. Yeah.
Okay. So class is over.
Okay. Let us leave.